Good morning, good afternoon, and good evening to everyone. Thank you for being a part of 𝐇𝐢𝐥𝐥𝐞𝐬 Conference 2026. I am 𝐼𝐚𝐵, Brand Marketing Manager at 𝐇𝐢𝐥𝐴 AI, and I'll be your host for this session on Canal Mania and the Philosopher's Stone. We tend to talk about the AI revolution as if it were nearly built. Today's conversation argues it has barely begun and asks what's still left to invent. Before we get started, just a few housekeeping items. The session is being recorded in case you need to drop off midway. We'll have a dedicated Q&A at the end. And please do post your takeaways on LinkedIn or X with hashtag #TestMeConference. With that, I welcome Magnus, CEO and co-founder of Sanity, the content platform. Magnus brings real experience building tools that collaborate with AI on new abstractions and creating autonomous systems that still keep people in the loop for guidance and verification. Thank you for joining us, Magnus. The stage is yours.
Thank you. Thank you for having me. AI is astonishingly capable, yet AI spectacularly fails in many of the tasks you try to make them do. Both of these observations are true. I'm Magnus. I'm CEO and co-founder of Sanity. We build software that helps organizations structure and operate their content. And increasingly, that means figuring out how people and AI can work together. But I'm not going to talk about Sanity. I'm going to talk about AI. And I'm not an AI researcher. I'm also not an economic historian, but I'm a big fan of both. I'm a builder who keeps encountering this very contradiction. And my co-founders and I, we love to nerd out on how people and machines should work together. And I love to nerd out on the Industrial Revolution and what we can learn from them. So AI is astonishingly capable and it frequently fails. Like for example, this weekend, I did a full analysis of our self-serve pipeline. We're growing extremely fast in terms of users and the revenue is growing somewhat slower. And Claude helped me do a fantastic analysis over the weekend that I could ship off to my finance team to dig further. Yet last Wednesday, I tried to make a team of agents plan out a new feature on Sanity, and it failed miserably. It started planning, and it kept on planning and planning and planning. Dario, he claims that we're 1 to 3 years away from AGI, Artificial General Intelligence. Alex Karp, on the other hand, he believes in AI, but he says that the LLMs are completely and irresponsibly oversold. So I wonder, are we at the end or are we at the beginning? At the end of this talk, I'll hope you get some more insights to the contradiction, what is working and what is not, where we are in the Industrial Revolution, some of the things that we find interesting to innovate, and how you can contribute. So I started looking at history, not because history repeats, it rhymes, but I wanted to start to see if we could learn from history. And I actually had to go back before the Industrial Revolution. People were chasing something even bigger than artificial intelligence. People were trying to invent gold and eternal life. For centuries, alchemists searched for the Philosopher's Stone. And not just anybody, people like Newton. The stone was not really a product specification. It started thinking it as a stone, but then it moved to a liquid and other things. It represented the ultimate capability, mastery over matter. They never found the stone. But something more consequential developed. They learned how to distill, how to crystallize, how to heat and cool and measure and combine substances. They learned experimental knowledge. And over time, the myth fell away and something more consequential emerged, a new discipline, chemistry. That gives us a way to think about AGI, Artificial General Intelligence. It's similarly difficult to define precisely. It's the ultimate capability, general intelligence that can perform across an extraordinary broad range of intellectual work. Will we get there? My co-founder, Evan, who is very, very smart, he thinks yes. So I say, apparently he thinks of himself, or human, as super capable stochastic parrots. I'm a bit more skeptical. I may be more in the Jan LeCun camp of this intelligence not being smarter than cats, yet extremely, extremely capable. CERN technically turned lead into gold, the Philosopher's Stone. But did it really matter? I think we have a lesson from the alchemist journey. There is something deeper. Whether or not we find AGI or not, it's not really the big point. It may not really matter. And I for sure not want to really predict whether it happens. The more important lens is what we are learning, defining, and innovating on our journey. That will create technological and economical revolution that we all can take part in. So, lesson number 1, we are defining the chemistry of intelligence on our way to AGI or not. So where are we in the AI revolution? Are we at the beginning or are we at the end? Again, we can turn to history for perspectives. Then we have to move out of the laboratories of the alchemists, and we have to move into Britain at the beginning of the Industrial Revolution. You can broadly divide the Industrial Revolution into 4 different phases: the Proto-Industrial Foundation, Canal Mania, Panic and Crash, Railroads, and Revolution. Now, historians may not agree with me that that's exactly the definition of the 4 phases, but in looking at Carlota Perez's framework for defining revolutions and heavily simplify that and history, I think is a fair way to represent the Industrial Revolution, the first Industrial Revolution, into eruption, frenzy, crash, and deployment. So where are we then in the first AI revolution? You may argue that the eruption started with the transformers until we launched ChatGPT, and that the frenzy is what we're seeing today. People talk about a crash. We haven't seen it yet. Will it come? And what is the true deployment? Now that brings us into understand the current time we're in. We have to go to England in 1790. This was a time when the steam engine could power a factory but not really move anything. The locomotive didn't exist yet. There were no railroads. Standardized parts didn't exist yet. Steel was impossible to make cheaply. And the internal combustion engine, well, that was mere science fiction. Britain was building canals at extraordinary speed. Here, illustrated by the Bridgewater Canal, the first industrial canal. So Britain was building canals at an extraordinary speed because canal solved a real problem. They made moving coal, iron, and stone and other heavy material faster and cheaper than by road. Water transport changed the economics. Private investors poured money into canal companies, and engineers learned how to survey, build locks and aqueducts, move enormous quantities of earth, and coordinate projects at scale that Britain had never really attempted before. And some of these canal investments were excellent. Some of them were foolish, some of them were redundant, and some of them really failed. But the canal really worked. But was it lasting? You may never heard about Canal Mania before I talk about it today, because what we really heard about is the railroads. But Canal Mania is interesting, not only because it actually worked and was part of the development of the Industrial Revolution, but because of all the things that developed around it. Although railways developed later in the deployment phase of the Industrial Revolution, it built on the knowledge and the insight. It built on the workers, the navvies, that started creating the canals. And it took people and the disciplines and brought it forward. So, although the canals didn't last, well, they're still there, but they didn't end up being the most fundamental innovation of the Industrial Revolution, it may not really matter. And if we take the same perspective of our technology today, and we're in the frenzy, we may be looking at our canals. Then what are the railroads? Well, we can spend an extraordinary amount of time trying to understand that. People are definitely spending an enormous amount of capital into models, chips, and data centers, and networking, infrastructure, and energy. And those things matter, and we need them. But it's dangerous to assume that just because they dominate the current moment, they will define the future and final shape of the AI revolution. So what are the railroads? We can try to figure it out. We can pretend to try to figure it out to seem smart, but I would argue that it doesn't really matter. The models will improve, the agents and robotics and the world models and everything will get better. But the deeper learning is, what are we learning from the canals? What are we learning in terms of the technology around the canals and the current frenzy that could bring us forward in the Industrial Revolution? Because something that can be foundational and enormously valuable can be transitional at the same time. The Industrial Revolution as such is not just a sequence of better machines. It produced a new operating system for work. Again, if we go back to history, before the factories, much of the work happened in cottages and small workshops. An increasingly powerful machine, they created an organizational problem. How do you organize many people and machines around a shared production process? The answer became innovations in their own right. Division of labor, standardization of process, system for scheduling, supervision, and for quality. The factory is an organizational technology. And the Industrial Revolution produced a new operating system for work. That gives us a different way to think about AI. Today, we often imagine inserting AI in existing human organization, an AI software engineer, an AI researcher, an AI lawyer, an AI support agent. We take an existing seat and we kind of think we replace the person. That is probably the wrong abstraction. Agents and humans are very different. Agents are not digital employees. They don't have to fill a full workday. Although they never sleep, I think the better point around agent is that you can work 5 minutes a day, spin them up and spin them down. You can also parallelize them. You could spin up 20 of them. You could finally clone the way you want to clone your coworker. You can access the knowledge of the agent in a very different way. And also, they are programmable. Humans do not come with a README file. Humans use cognition in order to understand what is happening and what they're supposed to do. Agent works in a very different way. Humans are not fungible, and organizations are very different, which is why I believe we don't have one cookie-cutter approach to run an organization. It depends on the people, the task, the culture, the context of what you're trying to achieve. Agents, again, are very different. The fact that they are programmable, at least to some degree programmable, depending on how you approach them, that means they can structure work very differently. They don't need to work all day, as I just mentioned, and their content can be deliberately assembled. It could be programmatically described, and the work can be checked programmatically. Corrupted context can sometimes be disregarded, and it could be rebuilt. So human and agents are very different. Together with my co-founders, I've been exploring how to work with agents in that context. I work with a lot of brilliant people, and one of them is my co-founder, Simon. And in December, after the release of Opus 4.5, he called me and he couldn't sleep. He had been building a new system, and he called it Myriad. It was a system that enabled a myriad of agents to work together in one place. It looked a bit like Slack. And he found that he could abstract the work and do a lot more when these agents were working together. We actually also released this. You can find the link in the notes. Now, one of the innovation he did was to handle memory better over time. But I think the big innovation was starting to think about how human and machines work together. For some of our engineers and for Simon himself, this gave more than 10x input on top of Claude Code, on top of already good existing AI tooling. 10x output. But it came as a substantial cost. We could easily rack up $4,000 a day. And we could easily also see that it was some days it ended up being more than $10,000. But a bigger problem was even the net effect. We saw that more agents give more chatter, more meetings in their own little Slack, and less output. They become chatty, maybe a bit like humans. So we continued to innovate, and Simon later came up with a new concept that he called persona. Persona is a system that is more of a direct delegation from a human to an agent. But then we let agents collaborate on the back end directly between each other to split up the work and define the different pieces to reduce context. And it really worked. Part of the innovation was really that we saw more than 90% cost reduction with the same or better output. This is an example of me releasing a new feature into production, not writing a single line of code, just talking to the agent who then works with a team of agents. That was amazing. I would go to bed and the next day I would see that. Yet some days I would go to bed with a perfect plan and I wake up and nothing has moved. The agent just didn't do it. Well, he delegated, but nobody followed up. And the whole 8 hours of coding that I was expecting the machines to have done was nothing. So this also didn't work. We're now on to our third version of this system. I'm not going to talk more about Sanity, but the learning of this is the different abstraction levels of how you work with agents is a very interesting topic and is far from explored. With agents, delegation becomes programmable. We know a great deal about delegating to humans, but how we put together a team of humans and how we follow up when we do work, that's not representative to how we control machines. With humans, delegation is largely informal. Manager communicates intent, people interpret it, they ask questions, you report progress, and someone eventually, hopefully, check the results. I think it's often very helpful to think about agents as humans because they're trained on human communicated knowledge. Yet agents, they require a lot of other things that humans don't require. Clarity, context, checkpoints, and correction in a programmable way. So when you're thinking about how you're going to work with the agents, it creates a different way of thinking about collaboration, and it creates a new design space. The interesting question to me becomes much larger than the prompting itself. What is the right abstraction level for organizing intelligence? There is a useful metaphor for this, especially for you developers. Right now, humans often communicate with agents on a very low abstraction level for it to work. We write prompts, we manually provide context, we split the task ourselves, we decide how the check should occur, we notice failures, restart work, etc., etc. Or if you're doing a simple linear task, you just ask Claude to do it. That may eventually look like programming in assembly language. Assembly language is the bridge between binary code and the higher level programming languages. A more mature system for human and AI collaboration could let the person express the intent at the higher level. This is what I find to be interesting. And yes, it works for simpler tasks when you work only with Claude, but try to abstract the work and have the agents work in a team to solve a more complex problem over time at a different scale, and that fails. The compiler is not a product, is not one thing. I think it's a metaphor for the missing layer of abstraction between needling and whispering to an agent and being able to talk to a team of agents like humans. I think delegation has a lot of parallels with how we work with human, and what we're seeing is a level of abstraction up the way leadership in many ways work as abstraction up. But the big learning to me is that we need a system to organize human cognition with artificial intelligence for these machines to work together. Okay, but you may say, Magnus, cool, you're nerding out on this. It's a little bit fun. What's in it for me? Again, I'd like to go back to history. You can take all the parts. You could take, let's take the lesson up front. You can all take part in this revolution because defining the compiler is a lot of work. Now, you don't have to work in an AI lab to have impact on what comes next. They will for sure have a lot of impact on what comes next. And scale is a bitter lesson for AI. For sure, the models are capable, but the real life applications, the systems and the implementation matters a lot. And it needs a different kind of innovation. Let's again look at history. Let's look at the people behind the Industrial Revolution. We tend to remember Watt, Stephenson, and Arkwright, the famous inventors. They were unique, and industrialization needed them. But it also required vastly more people than the people who invented the headline machines. It needed the clockmakers, the blacksmiths, the machinists, the surveyor, the civil engineers, the navvies, etc. Often transforming their former knowledge into new practices, driven by rethinking their craft. You see, people who understand one part of the system deeply enough to make the rest of the system possible. The AI revolution will not be built only by the people chasing the Philosopher's Stone. It's going to be built by the people who are inventing chemistry, who are digging the canals, people who are figuring out how the factory should really work. That opportunity is still wide open in AI. You don't need to train the next frontier model to matter. So, lesson number 4, we're building the operating system for intelligence, and you can take part. Someone needs to figure out how machines receive intent, how they divide work, how they coordinate without polluting their context, how they know when they're finished, how we know how to check their work. How do we reinvent leadership when humans and machines work together? Somebody needs to find the organizational structures and the language to represent them. That's going to be obvious 20 years from now. I would claim that we don't know what most of those inventions are yet. That is precisely why this moment is so exciting. Again, we tend to imagine that revolutions are created by giant breakthroughs, the Philosopher's Stone, the steam engine, the frontier model. Maybe AGI arrives. For sure, models will become extraordinarily more powerful. Maybe we will build the railroads. But between here and there, there's an enormous amount to figure out: how we organize, how we enable, ways to think about the new system. So hopefully you have one takeaway from my talk today. This is an exciting time, and you can be part of the AI revolution. We at Sanity for sure will. The 4 lesson I draw from looking at history is we're defining the chemistry of intelligence, not chasing the Philosopher's Stone. You don't need to be able to predict the next railroad in order to engage and have impact on the revolution. We need a system to organize human cognition with AI. We need a compiler. And again, you can join the revolution. Build around the core technologies. That is not cleanup. That is the revolution. Thank you.
Thank you, Magnus. It was a wonderful session. Maybe we can take some questions.
For sure.
Yeah. So I'm just popping a question. So yeah, when an AI agent produces different outputs for the same input, how do we distinguish acceptable non-determinism from an actual defect?
That's a very good question. Bharat, you're smart. Why don't you go and try to figure that out? Because I don't have the answer to that. But I do believe that the intersection between probabilistic and deterministic is very important. We're spending time on defining certain technologies. We're going to release it now on our conference in New York in September. We try to structure content in different ways and mix probability with the deterministic knowledge, because I do believe the total probabilistic approach is not enough. Obviously, I'm biased with what I'm working with, but I believe it's a great question, and I would love to see how you think about it. DM me.
That sounds good. Now we can take the next question. So it goes like, how do you design prompts that allow the agent to ask clarifying questions without frustrating the user?
That's also a very good question. And again, I don't have a silver bullet for it. I think defining the work system, as I said, human organization is not one size fits everybody. And I believe the same will be true with interaction with AI. It depends on the kind of craft you're doing. I think that would be different, but it also depends a lot more on the abstraction level. So what we're seeing building out our systems is that, for instance, Simon, my co-founder, who's our CTO, and is very deep on architecture, he don't get frustrated, or less so, when going down and splitting up the tasks. He also has a lot more time to spend with these machines. While I'm being the CEO and having a lot of other tasks, I spend much more time, and I need to break down what clarifying questions. And again, I think, go back to the organization in humans, not because agents are humans, I made that point, but what kind of follow-up questions frustrate leaders or colleagues in an organization? There is no one bullet answer to that. So I do believe that we have to find ways to define the context of how work is done, not only the context of what the answer is. You know, one of my lessons, there's a good book by Eric Schmidt about Bill Campbell, the $1 trillion coach. And one of the things that Bill said was, when you have a problem, the first question, the most important question, is not what is the answer, who is to solve that question.
Very rightly said, Magnus. So we'll take the last question, and it's, how do you even test a voice agent's prompt, audio or transcript level?
So I need to understand that. How do you even test a voice agent's prompt? We have not spent a lot of time. Actually, I can take another question. I don't have any insights to that.
Okay, we can go for another question.
I'm sorry. Now I'm curious to explore that, but I haven't.
No worries. How should sound or sight, etc., accessibility be incorporated into system prompt design for voice agents?
Oh, another amazing question. I would love to nerd out on that. But again, we're talking voice agents, and that's something I haven't really spent time of thinking about. So I don't think I have anything great to add to that. If you have more questions that it's more about like the system and delegation of work, that's probably something I have better insight on. Or more reflections on
something around machine intelligence. What elements of machine intelligence are the least compatible with human intellect? How can those differences be bridged?
Yeah, that's a very, very interesting question. The least compatible. Okay, the fun answer is time. which annoys me, and we have to solve it. The machines can't understand time, and it makes planning. Time is a very useful concept. I mean, it's a helpful thing, because the agents think they are humans. They think in time, but they operate on a different level. I do believe, though, that the more maybe serious, profound answer to this, the difference is maybe we could say the context window and how to think about it. I do believe agents should be much more narrow. So there is obviously a difference between training a very capable model and how you operate the context around that model. And a lot of what we do is context engineering. We don't try to invent better LLMs, although we have been considering whether we should fine tune and do other things with LLMs to explore this further. But in the context engineering, I just think that machines have a very different approach to context, and that our reference point of humans taking context and doing something with it is very, in a way you have to treat them like they're 5 and then a PhD genius at the same time. And it's very contradictory in our mind. So it's a very different way of thinking about communication and delegation and then context.
Right, very rightly said. So we are on the closure of our session. Thank you so much for your time, Magnus. It was a very insightful whole session.
Thank you so much for having me.
Thank you. Stay tuned for the further sessions. Thank you, everyone.